Okay, so I'm going to do version A, number 3, and then I'll give you the answers to version B, number 3. Now, the first thing you're asked to do is to draw a free body diagram, because if you look up here it says free body diagrams are 5 points each. So you could do one of several things. You could show me this, this, and that would give you all 10 points. If you didn't want to do it like that, I was fine with you simply doing that, 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 and that. The problem, and then you needed this weight here. The problem was about 60% of you failed to give me those little arrows. I'm supposed to know which direction the forces are acting. If you don't give me the arrows, I can't know that. So that was my free body diagram, 10 points there. Then I needed equations. So I would say that T1, all right, there's theta 2, there's theta 1. So T1x, so T1x equals T2x. 6 points right there. T2y, T1y, T2y plus T1y has to equal the weight. 6 points right there. Weight is mass times gravity, 3 kilograms times 9.8 is 29.4 newtons. So T1y, or T2y, is the sine of 25 degrees times T2. T1y was the sine of 40 degrees times T1, and those added up to 29.4 newtons. Alright, can't go any farther there, so I'm going to come over to my x's now. I'm going to say the cosine of 40 degrees, T1, is equal to the cosine of 25 degrees, T2. So T1 is equal to the cosine of 25 divided by the cosine of 40, T2. So the cosine of 45 divided by the cosine, the cosine of 25 divided by the cosine of 40 was 1.18 T2. So T1 was equal to 1.18 T2. So now I'm ready to go back in and plug in to my y values. So the sine of 25 is 0.423, 0.423 T2, plus the sine of 40 is 0.643, and then T1 was 1.18 T2, and those added up to 29.4 newtons. So I had 0.423 T2. I multiplied those together. When I multiplied those together, I got 0.756 T2 equals 29.4 newtons. So when I did the math and solved for T2, my T2 wound up being 99.51. I'm sorry, I'm looking at the wrong dadgum test. I apologize. That was for B. And I'm supposed to be doing A, so let's go back. So when I solved for T2, I got 24.9 newtons. And then T1, I simply came over here and multiplied 1.18 by 24.9 newtons. And when I did that, I got my 29.4. So my work got me 4 points, and then my answers were 4 points each, and that's all there was to it. If you had version B, let me give you the tensions for version B, since I tried to mess it up a while ago. If you had versions B, that was 117.43 for T1, and T2 was 99.5. Worked identical. The only thing we did different was we changed the weight. So that's for version B. Alright, so pause it if you need to, because I'm fixing to erase that and move on to number 4. Alright, number 4. Free body diagram is the place to start. So M1 has weight 1, tension, force normal, and friction. Again, you have to have arrows to show me that you know which direction the forces are acting. Mass 2 had weight 2 down and tension up. Okay, so now I want to do version A and then give you the right answer to B. So let me play around and see if I can find that. Let's go here. Okay, so that's what I had. I'm going to make this one be positive, this be negative, which makes this tension be positive and this friction be negative. So net F equals MA. So I'm going to start with tension minus friction is equal to M1A. I did M1 first. For the second one, I have W2 minus T equals M2A. I'm going to add those up. My tensions must cancel. So W2 minus F is equal to the total mass times the resulting acceleration. All right, well, let's get weight 2. Well, weight 2 is 18 kilograms times 9.8 meters per second squared. So when I multiplied those, I believe I got 100 and, let me make sure I'm not lying to you, 176.4. So there was weight 2. Friction was mu times force normal. Mu was given to you as 0.2. Force normal equals weight 1. Weight 1 was 12 kilograms times 9.8 meters per second squared. And I needed to see every bit of this. And I hope to see it on Thursday. So if I did that correctly, the friction wound up being 23.5. So 23.5. So now I have 176.4 minus 23.5. M1 and M2 are 12 and 18, which adds up to 30 kilograms, times A. So when I solved for my A, I got 5.1. And I want the tension now, so I'm going to go back to one of these equations. So right here, tension minus 23.5 newtons is equal to M1, which is 12 kilograms times 5.1 meters per second squared. So my tension wound up being 84.67 or 84.7. All right, if you had version B, your acceleration was 4.9 meters per second squared, and your tension was 58.8 newtons. Okay, again, you want to pause it because I'm fixing to clear it out, do number 5, and get on with my life. All right, you're going to be really sad when you see how easy this problem really was. Okay. So this is an AP problem from an old AP examination. Oh no, flip out, flip out. No, it's really very doable. All right. I want to find the force. Well, F is equal to MA. A is equal to BF minus VI over T. It starts from rest, so BF is that 20 meters per second. And I don't care anything about the angle because I'm kicking it at an angle. So 20 meters per second minus 0 meters per second. And it tells you in the problem that the ball is in contact with the foot is in contact with the ball for 0.05 seconds. So the acceleration wound up being 400 meters per second squared, and it doesn't matter which test you had, it was the same. So F is equal to 0.5 kilograms times 400 meters per second squared. Half of 400 is 200. There's my force. That was 3 points. So again, pause it because I'm fixing to move on. If you want to look at that, shut it down, pause it, and then I'll keep on trucking. All right. So B says determine the time it takes the ball to reach the plane of the fence. Well, dx equals vxt. They told you that it was 32 meters to the fence. Well, if that angle was 37 right there, and this is 20 meters per second. On the test, it gave you the cosine because they wouldn't let you use a calculator. Cosine of 37 was 0.8. And if you used your calculator, you got 0.79 something, that's all right. So if that's going to be, cosine is 0.8, and I'm going to multiply it by the hypotenuse of 20, then Vx is going to be 16 meters per second times time. If you solve for time, time is 2 seconds. All right, so that was another 2 points right there. Now, this one's a little bit harder, so let's see if we can tackle it. It says, will the ball hit the fence? If so, how far below the top of the fence will it hit? If not, how far above the top of the fence will it pass? All right, so what I said was, well, I know that VYF equals VYI plus GT. To get to the highest point, this has to go to 0. I use the sine of 37 times that hypotenuse of 20. On the way up, gravity is negative. So I found out that it went up for a grand sum total of, I think, 1.22 seconds, but let me make sure that I'm telling you the truth. Yes, it rose for 1.22 seconds. If the total time of travel was 2 seconds right up here, then it would fall for 2 seconds minus 1.22 seconds. So it would fall for 0.78 seconds. Now, how high does it go during that 1.22 seconds? Well, VYF squared minus VYI squared over 2G. And when I did that math, I figured out that it went up 7.35 meters. Now I need to find out how far down it falls. So I said dy equals 1/2 GT squared plus BYIT. Well, as it begins to fall, this is 0. So I found out that it fell. When I did it, I got it falling 3 meters. So that was 4.35 meters from the ground. The fence itself was 2.5 meters tall. So it was 1.85 meters above the fence. So no, it did not hit the fence. So again, if you want to pause so you can see this, that would be great. I'm going to finish the last one. Okay, so you were asked to plot the velocity versus time for the horizontal and the vertical. The horizontal was 16, it never changed, and it lasted for 2 seconds. It was that easy. Okay, the vertical, it started out at 12, and at 1.2 seconds it was 0, and so you had to draw a straight line, and I'm not going to be able to do it very well on this little right pad, but that's what it looks like. 3 points here, 2 points there, done. Please study.